so now we've got our radius is 0.15 and our RPMs is 33.3 revolutions per minute. Okay, so we've got enough information now. So I put some formulas over here so that we can kind of look at this and see what we've got here. Okay, so the force of friction is going to equal force centripetal. Well, of course, doesn't that make sense? The object is going this way, and that's going centripetally toward the center, so it has to be the same. All right? So mu of F of n is going to be the same as our acceleration centripetally. So therefore, mu F of n is going to give us our centripetal acceleration. So if we substitute mg in for F of n, because those two numbers are the same, these have to be the same, because remember, the object is not moving up and down, it's only moving in a circle. So therefore, we've got mu mg equals mv squared over r. So let's, oh wait a minute, we have m on both sides, so those will disappear. And if we take g and we move it over here, we will get mu equals v squared divided by rg. And there it is. Okay, so now we did that part. So we've done the formula part. Now we just got to stick in some values here. All right, so let's see. This is going at 33.3 revolutions per minute. Okay, but wait a minute. We need time. We need seconds per revolution. So we're going to have to multiply this by minutes over seconds, right? So we should get revolutions per second first. So let's see, 1 minute is 60 seconds. So when we multiply that out, we get 0.55 revolutions per second. Well, wait a minute, that's revolutions per second. So we need to know how many seconds per revolution. Oh boy, so now we've got to get 1 second over 0.55 revolutions per second so that we get our answer in seconds per revolution, which is known as the period. So we've got seconds and revolutions per second. So when we divide this out, we get let's see, where can I put this here? I can put it here, 1.80 revolutions per second, or our period, or our time. So now let's see. We want to find our velocity centripetal, which we did before, which was 2 pi r divided by t. Well, we now have t, we have 2, we have pi. So now, to find velocity centripetal, so we've got 2 times pi times r, 0.15, divided by time, which is 1.80, okay? Now we divide that out and we get 5.24 meters per second. Well, let's see, this is seconds and this is meters, so meters per second. Okay, so we're in good shape there. Oh, that's, yeah, okay. Okay, that's period, right? Okay, so now we just take here and we say, okay, we want to find mu, which we don't know. And we've got v squared, so 5.24 meters per second squared divided by our time, oh, wait a minute, nope, that's wrong. I got to read my equation here. The radius, which is 0.15 times 9.81. And that will tell us mu. So if we divide that all out, let's see, this is here is seconds, and this is meters per second squared. So, wait a minute, that's seconds squared, that's meters squared, that's meters, so they all disappear. So everything cancels. Oh, wait a minute, that's right. force of friction mu doesn't have a unit. So the units are all going to cancel out here. So we get our answer is 0.187. And that is the answer to our question. What was the friction needed in order for the object to stay on the wheel? So if we remember our wheel here, and here's our object, in order for this to stay on the wheel and go around, it can't have a friction, a force, greater than 0.187, or it will slide off. All right, our third problem. We've all seen a lifeguard or someone who's twirled a whistle and it's gone around in a circle in this direction. So now we're going to be in a non-uniform pattern. All right, so this would be just like the example that we did for the Ferris wheel. So I put the equation up here for the Ferris wheel. F of n equals MAC, which is acceleration centripetal. So, and that equals mv squared over r. So, okay, so the string here that's holding the ball, this string here can hold 14 newtons of tension. So this is going to be T. And let's see, it's swinging around at 0.5, so this is our radius, 0.5 meters. And the mass of our object is so this is our mass. Okay, so the question is, what is the maximum speed that the ball can have right here at the top of the circle? What's that maximum speed in order to have 14 newtons of tension on the string or on the rope, okay, with a 0.5 meter radius, so that part there, and it's a 0.25 kilogram object. All right, so now what we got to do is we got to just fill this in. It's really not that difficult because F of n equals T plus mg, because the tension's going that way. So we're all set there, okay? And MAC, well, we know that that is force net is MAC, Newton's second law. And we know that acceleration centripetal is mv squared over r. So we really got this pretty easy here. T plus mg equals mv squared over r. Well, that looks great to me. Oh, can we get, oh, wait a minute, we can't cancel out the m's because our tension out here doesn't allow us to do that. So let's see. Well, how about if we get rid of the division? If we multiply both sides, so we have r t plus mg equals mv squared. Looks like a pretty simple equation. So now, well, let's just see here. What do we want to try? We want to find velocity. So if we want to do that, we want that over there, so we're going to divide both sides by m. So r t plus mg equals v, oh wait, no, it's over m, is m. This doesn't sound very difficult now. Let's see, the radius is 0.5, the t is 14, plus mg is 0.25 times 9.81. So I get all of my things here straight. Okay, 0.25, there we go. All right, equals v squared. Oh, wait a minute. We've got the mass underneath, so we're going to divide it by 0.25. Well then, because I'm going to run out of space, if I take the square root of that, I'll have v. Ta-da! So all I got to do is plug in all the values, and I have the velocity at the top there is 5.74 meters per second. Okay, so now we got to check our units here. Our units are all over the place. So let's see. This plus this happens in the parentheses first. So this is kilogram meters per second squared, and this is kilogram meters per second squared. So we're adding those together. So we're going to get kilogram meters per second squared with a meter outside of it, okay? And we're going to get a kilogram on the bottom. So kilograms and kilograms, and then we've got meters squared, seconds squared, but we're taking the square root of that, so we end up with meters per second. So our units do check out, and 5.74 meters per second is the velocity. So that gives you 3 examples. I'm going to give you 4 problems to do, and that'll be on a separate sheet for you. All right, good luck.